Okay, section 7.3, angle relationships in polygons. So here we're looking at, again, just angles, and we're coming up with a couple mathematical relationships, and you'll have to solve a couple equations looking at angles in a polygon. So first of all, some terminology, and of course our goal, I guess, is to figure out, depending on the number of sides, what the interior and exterior angles are. A regular polygon is what not only what we're going to be talking about, but we do often, and that just means all the side lengths and all the angles on the inside, are equal. So if you look at any of these, you remember these shapes from elementary school: octagon, nonagon is 9 sides. It doesn't really matter that much, but what matters from my point of view is that you know that in a regular polygon, every side length is equal, so it's a square specifically, and every angle on the inside are equal to each other. Okay, so all the side lengths and all the angles are equal, as opposed to a non-regular polygon, which might look like this, where you have, well, that's a regular and there's an irregular, right? There's a 4-sided shape, an irregular polygon. Okay, you don't need to draw all those. Please don't take the time to. I just want you to have the idea, and so you remember, and if you hear the terminology. Okay, so here's the rule. With interior angles, the inside angles on a polygon with any number of sides, and we'll use n to be specific. N sides. So, to be the opposite of specific, to be general. The sum of the interior angles is always the same. You can always figure it out, no matter how many sides are on the triangle, by just subbing in for n. So the interior angles is 180 multiplied by, so I have no times sign, it's just because there's a bracket, multiplied by n minus 2. Okay, and if you just want to see what I mean by that, if you're looking at a pentagon, you might remember a pentagon is 5 sides. So when you use this equation, you just go 180 times, instead of writing n, you write 5, because it's a pentagon, minus 2, 180 times 3, which is 540. So the sum of all the interior angles inside a pentagon is 540. Exterior angles, on the other hand, is always 360, no matter what. And when we did triangles, it was 360. We did quadrilaterals, it's 360. Well, the point is, it doesn't matter what shape it is, it's always 360. Okay? So exterior is always the same. Interior, you use this formula. So my example then, what if you have an octagon? Octagon means n equals 8. You sub in n equals 8 into our formula, and you get 1080. Now, it says there, next example, if that octagon is regular, because it's not specific, it doesn't have to be regular for this to be true, for the sum to be true. However, if it is regular, then all the angles are equal to each other. And then if you want to find out what that angle is, you just take this number and divide by 8. And that's going to be the angle for every single one. It's going to have an angle of, in this case, 135. Okay? So if it's regular, to find the size of each angle, the measure of each angle, you just take the sum and divide it by the number of sides. This next example is a little tougher. In this next example, we get to do some solid algebra, our first real chance in this unit. We know that we have some polygon that's regular, and we know that it has 144 degrees is the interior angle. So that means that every angle inside that polygon is 144, but we have no idea how many sides it has. So we're going to say n is the number of sides. Let n be the number of sides. So what we know then is, because it's regular, if we want to know like the sum of all the angles, it's going to be 144 times n, right? So if it was a 3-sided shape, well, it couldn't be a 3-sided shape, but say it was a 6-sided shape, the sum of the interior angles would be 144 times n, because it's every single one is 144. And so if it's a hexagon, it would be times 6. But we don't know if it's a hexagon. We don't know what it is. We just know it's n. Okay? So The other thing we know though is that, and we use this is just the general rule. So it's like we know that it has to be 144 times n because each one is 144 and n is the number of angles. Well, the sum is 180 n minus 2. That's just the rule, right? That's just the rule all the time. So that means these two things are equal to each other. Those two are equal to each other, so you can do that. You can equate them right here, and we're going to solve for n. And if you just follow my train of thought, I did the distributive property right here. I multiplied 180 times n, 180 times negative 2, and I get 180 n minus 360 equals 144 n. And I'm just solving for n here, so if you follow the steps, I'm going to bring all the n's to one side. So I'm subtracting 144 n from each side. That's what I did here. And I end up with 180 n minus 144 n is 36 n, so 36. Then I have this minus 360. I got to bring it over, so I add it to each side. And step, 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 n equals 10. That means this is a 10-sided figure. Okay, so this is the hardest type of question for this one. There's not much else I can do to make it harder, so if you see one, please, if you see one in your homework, come back, read the example, follow the steps. Chances are your homework question is not going to be n equals 10, but it's going to follow this same pattern. Okay? I think that's it for this lesson. Yes, it is. So go ahead, maybe before you even finish for the day, try a couple questions just to make sure you get it, and then come in tomorrow ready to go.